doing the ultimate speed run lesson. If I can speed run Mario, I can speed run CO2. Sure. And we are, I hope you enjoyed your break from, here you go, Andrea. I hope you enjoyed your break from algebra because we're going back to algebra to solve for segment lengths. One of the characteristics of a segment we talked about yesterday is measuring segments and finding segment lengths. I see it, kids. I see it, and
One more time, Mr. Schultz.
So, what does the word congruent mean?
No.
Real.
I don't know.
The same. Right?
It's different.
And how we're talking about the difference between a congruent symbol and an equals sign is this example here. The equal sign means value. Okay? The lengths are equal. If two things are equal, it means they have value. If you're saying something is congruent, you're simply saying it's the same. You're not talking anything about a specific length. You're not talking about anything with value. Congruency is simply same, no value. Equal, they're saying their values are equal. Their values are what the same. Okay? A $1 bill is congruent to a $5 bill. They're the same size, same shape. They are not equal, however, because their values are different. Okay? You see the difference?
No.
Do you understand if $1 bill is the same size and shape as the $5 bill?
Yeah.
They do not have the same value. The second addition postulate, this is the first of several postulates and theorems that we're going to talk about. You will have postulates and theorems tests to where either I will give you the postulate and you either give me the definition or draw me a picture that shows you understand it, or I'll give you the definition or a picture, you need to tell me what postulate it describes. So whenever you see the word postulate, this should definitely be taken into consideration. Care about it. Put it on a help sheet. Learn it. Know it. Okay? And the first one, the segment addition postulate, says that the parts of a segment add to equal the whole segment. Okay? The parts of a segment add to equal the whole segment, which is why if I give you a third grade level question such as this, telling you that the length from F to H is 36 and the length from F to G is 21, what is the length of G to H? Chase. Oops, Chase has the floor.
15.
And how'd you get that?
Because 36 minus 21 equals 15.
Right. We know that because of the segment addition postulate, these two parts, FG and GH, have to add to equal the whole thing, FH, which is 36. Okay. Now you'll notice this has arrows on each end, right? And so we also have line FH here. But if we are specifically talking about from F to H, we're defining that segment, that part of the line, that piece of it, as 36. And the parts of FH, 21 and what ends up being 15, have to add to equal 36. Right? They always will. Geometry, there are no exceptions.
What if you make a whoopsie?
Yes.
I have a question about the lengths are equal to like AB equals CD. So could that mean that the lengths are equal, but one is worth like 10 and the other is worth 50?
Well, that wouldn't be equal lengths. Are you saying like if they're drawn to different scales? If the lengths of two things are equal, one can't be 10 and one can't be 50. Next one, WX, same situation. From V to X is 144. From V to W is 37. The algebra here, I mean, if we label this a variable n, the algebra is 37 plus n. 37 plus what number is 144, right? What missing value makes the two parts of these segments add to be the whole? What do we get?
107.
107. Okay? 107. That's the theory behind the segment addition postulate. Now, of course, the questions on your tests and your homework won't be quite like that, all of them. We're taking it next level. And slightly more complex examples, it says point B is between points A and C. Does this statement tell us where point B is in relation to A and C, like which one it's closer to? No. Is it telling us that it's exactly in the middle? No. It's saying it's between. Okay? So when we draw this out, we're going to draw a segment AC. We know that A and C are the endpoints, but we're going to stick point B somewhere in between them. Right? Doesn't matter exactly where. All the information we have is that it's between. Right? Then we're told that AB, the distance from A to B, is 2x plus 7. Right? From A to B is 2x plus 7. And notice here, I'm writing it right in the middle of A and B. That's how you can kind of tell when a measurement refers to a specific part. It's written in the center of it. Like up here, when we had 37, we knew it was V to W because it's written in between them. We knew that 144 is between V and X. It's written between them. Also, it's got the brackets to kind of help us there, right? But values are written in between the points that they correspond with. We also know that from B to C is 7x minus 8. So from A to B is 2x plus 7. From B to C is 7x minus 8. And we are told that from A to C, the length of the entire segment is 80. What algebraic equation are we going to be setting up here that's going to allow us to ultimately solve the variable? There's your algebra. But then give us the values of A, B, B, C. Jocelyn.
2x plus 7 plus 7x minus 8 equals 80.
Exactly, right? The segment addition postulate tells us we know that the parts of the segment, one part is 2x plus 7, right? From A to B is 2x plus 7. From B to C is 7x minus 8. So 2x plus 7 plus 7x minus 8, those two parts added together equal the whole segment, which is 80. It's 80 because you're told that. AC, the whole thing, is 80. Paul?
You go over it one more time.
So A to B is 2x plus 7, yes? B to C is 7x minus 8. Let's just say, Paul, that this was 2 and this was 3. What would the whole segment be? And how'd you get that? Right. So we do the same thing here. 2x plus 7 plus 7x minus 8 has to equal the whole segment, which we're told is 80. Nick.
But then how would you find X?
How would we find X?
I know the answer.
How would we find X? Caitlin.
First, you need to combine like terms.
Yes. Algebra. Combine the like terms. We have our variable terms and our coefficients. 2x and 7x is 9x. Nope, this is algebra. 7 minus 8 is negative 1. And that equals 80.
Easy then.
We now have a two-step equation. Add 1 to both sides. Divide by 9. And x equals 9.
That's light work. I got that, Mr.
Right? Maddie.
I thought I knew it.
Now this is one of those situations that we've seen this before, where solving for a variable isn't always the answer, right? The question being asked is find A, B, and B, C. So if x is 9,
Plug it in.
plug it in. 2 times 9
18.
plus 7 is
25.
25. 7 times 9 minus 8.
Minus 8 is 55. 55. 55. 55.
And how can we easily check our answer and make sure that we are correct, Paul?
Equals.
You add them together. 25 plus 55 does equal 80. Now, looking back on this, did we put B in the right spot? No. But that's the thing about sketching. With geometry, don't worry about how your diagram looks as long as you take care of what you know. All you knew was that B is somewhere between A and C. We did that. We ended up putting it on the wrong side of half because 25 is not longer than 55, but that doesn't matter, right? If we were to then actually draw this the way it's supposed to look, we'd put B closer here because it's shorter, whatever else. But with sketches, don't worry about that, okay? Cool.
So for like the next one to the right, it's you define it's A whatever. You define AB and then AC and then AB and then BC is the equation. So then.
Yep. So you set it up the exact same way and solve for the variable. Nick,
It's different.
So
it is. Set it up the same way. Solve the variable.
Wait.
I'm confused.
Excellent. Practice it tonight. I'm gonna have you do this one for tomorrow. And in your book, I told you I
Gotta
could
go.
do
It's
it.
time to go. It's a minute
Well, then
after.
don't write this 7 down and get it incomplete. That's up to you.
Sounds good.
In your book, you are to do on page 12. Six
Yelling at you.
We don't see how many.
6 through, shut yelling at me.
I can't.
6 through 11,
That equals 2.
and then 21 through 26.
Oh,
Okay?
like a lot of words.
That's like.
I told you you have to get going, folks. Get out of your seats. It's time to leave.
Oh, yeah, blame it on us. Oh, yeah.